So Dr. Francesca Braca is researcher and project manager at Laboratori ARCHA in Italy, and she manages and coordinates European and national projects in the field of management, compostability and recycling of waste, health and safety risk assessment, life cycle assessment, and life cycle cost studies. Her presentation title is End of Life of Material, Biodegradability and Compostability Assessment. Please, Francesca, the floor is yours.
Many thanks, Mara. Please let me know if the screen is okay, if you can see the presentation. I hope yes. Okay, yeah, perfect. Thank you. So, yes, I'd like to provide you some preliminary results for the assessment of the end-of-life behavior of the developed materials from ECOFUNCO project, especially in terms of biodegradability and compostability performance. Let's say the problem, the aspects of the end of life of the packaging is very well known, but I think that we need to focus the attention on the on some specific behavior of this material in several environments. So I'd like to provide you some results, some methods and tests to look inside the performance of the material, and also which are the specific tests and methods to assess these aspects, and some main conclusion at the end about our results. So, well, the plastic and packaging materials are used always for lots of application. In particular, we can provide lots of examples for food, thanks to their properties to provide long shelf life for food inside, for the especially for the availability at all times, so we can have food where we want, where we need, and in all the situation. So the problem is the accumulation of this plastic material in the environment. The possibility from nature to degrade these materials is provided, but we need to assess that some micro and nanoparticles can be produced, so we don't have the disappear of the material. And so we need to underline that we can have accumulation of toxic and carcinogenic chemicals to the soil, to the sea, in several environments. So this could provide also the accumulation of this particle in the food chain, since from soil can migrate to the food, let's say. So the problem is the waste management. What is going to happen when a product is at the end of life and it is landed or landfilled at the end? The process of biodegradation naturally starts. It starts because and thanks to the activity made by microorganisms that can degrade the organic matter into CO2 by, let's say, passing through other molecules, simplified molecules, but we need these activities made by the microorganism. So biodegradation process has a great potential in reducing waste, and especially in waste for waste impact and amount. Unfortunately, it is not a simple disappearance of the waste, but it depends on the specific biological environment. There is a very interesting video on the TÜV Austria website that you can see. I provide here the link, and if you want, we can share in the chat, I think, where we can see several microorganisms that can provide this process to the materials and to product at the end of life. I try to summarize some general information, especially thanks to several certification schemes that we can find on the TÜV Austria website for the assessment of the end of life of this material. In particular, first of all, the OK Compost Industrial Scheme, the first on the top on your left. You can see the label of these certification schemes. This is the way to assess the end of life under controlling conditions, in particular under industrial controlled conditions for composting, and we can find it, for example, on the biodegradable shopper that you can find in the supermarket, for example, for fruits and vegetables. This means that in an industrial pilot plant, the material is biodegradable and also compostable. Sorry. And also we can provide the OK Compost Home scheme. The OK Compost Home schemes means that the material can be composted in home composting plant. In our garden with our organic waste, not in the industrial plant. In the center, you can see the OK biodegradable schemes. These are related to marine, soil, and water end of life scenarios. So these are, let's say, in situ biodegradation assessment and protocols. On your right, there are the bio-based content protocols and schemes to verify and to certify the amount of bio-based material in the raw materials that you can use. So this is just an overview of the possible certification schemes that can focus the attention for the end-of-life scenarios for the raw material and packaging and final products. Indeed, I have to just sponsor my company, Laboratori ARCHA, that is located in Pisa, since we are a recognized laboratory to provide the official tests and methods for the application of the schemes, of some of the schemes that I have described before. For example, we are recognized for the OK Compost Industrial, OK Biodegradable Soil, and OK Compost Home schemes. Thanks to this recognition, we can provide to the ECOFUNCO project the official analysis and test methods for these schemes. And starting from the industrial compostability, we can provide the analysis according to the N1342 standards related to the requirements for packaging recoverable through composting and biodegradation, with all the 4 schemes for analysis and evaluation criteria for the final acceptance of the packaging, so for the final certification of the packaging. These standards start from the chemical characteristic, chemical analysis, in particular in terms of the quantification of the heavy metal and fluorine contents in the materials, in the packaging, in the plastic material. We have a specific limit to comply with, and we can provide these results on all this plastic material and verify the compliance for these first parameters, let's say. Then we can analyze the samples, the materials, according to the analysis of biodegradation. I will describe you just after this slide. in addition for the disintegration test and the ecotoxicity. These are the three, let's say, main tests that we need to perform to assess the overall compostability of the packaging material. So, sorry, the animation. About the end-of-life behavior, as I can say, just to give more details, we need to assess the packaging composition. This is for the industrial compostability assessment. And for the packaging composition, we need to provide the thickness, since this parameter is very important for the disintegration test. Since as thick as the material is, as less is the disintegration test, and the material could not comply with the requirements. So we have also to verify the compliance with the specific limits of the heavy metals and fluorine concentrations in the raw material, and the volatile solid contents more than 50%. This means that the organic carbon of the material is with a defined concentration. Then the second step is the biodegradability. The requirements for the industrial compostability is that more than 90% of the material, of the organic matter in the material, is biodegradable within 6 months. So we need to start the test and every day measure the CO2 that is released from the sample. I can provide you also some picture and some information just later on. For the disintegration test, we have to verify that less than 10% of the material remain with dimension more than 2 millimeters after sieving of the final material and after 12 weeks of composting process. Finally, we need to analyze the compost quality in terms of the agronomic composition, let's say the agronomic parameters that we need to assess, for example, pH, volatile solids, organic carbon, nitrogen, dry matter, and so on. We need to analyze and quantify the residual heavy metals concentration in the final composted residues, since also in this case we have a specific limit for fertilizer, for the regulation of fertilizer to provide a compost with a good quality in terms of fertilization and in terms of the absence of toxic substances for the soil and for the plants that we want to have at the end. And finally, we have to analyze and verify the compliance for the eco and phytotoxicity test. All these analyses, especially biodegradability and disintegration in terms of composting process for the industrial one, needs to be performed at high temperature, more or less 58 degrees for biodegradability and more than, let's say, 60 for disintegration, especially in the first period of the process.
Excuse me, Francesca, you have 5 minutes left. Thank you.
Thank you, Mara. Sorry, I speed up. The biodegradability test is performed according to the ISO 14855. The test method is run in a defined vessel with the air that is fluxed inside and the quantification of the CO2 at the end of the at the exit of the vessels. So the percentage that I can provide, you can see here the picture of the equipment in our laboratory. The final percentage can be defined in compliance with the requirements of the methods if all the material and the packaging that we want to test is more than 90% and within the 6 months of the test, and we can stop the test as soon as we reach this percentage. For the disintegration test, we put according to the official standard ISO 16929, we put pieces of material, it depends from films or final products, according to the standard in pieces, and at the end of the 12 weeks of the test, we need to sieve the material and quantify the amount that is bigger than 2 millimeters, and verify that this amount is lower than 10% of the initial materials that we start with the test. Also in this case, you can see some pictures, some preliminary picture after defined days elapsed for the test, and we need to assess the aspects, the general aspects and appearance of the final compost coming from the blank sample, so without the plastic material, and the one obtained with the packaging material. And we need to weight this amount and to evaluate if this percentage is lower than 10%. Finally, the ecotoxicity assessment is performed according to the OECD 208 for the seedling and seedling growth test, assessing the growth index of the biomass by using two different plants seeds that is added at 25 and 50% of the final compost obtained by the disintegration test. In this case, we can see that the plants can grow properly, with the germination rate more than 90% for both the added concentration with both the plants, the barley and the cress. Final, we would like also to perform this test according to the home compostability assessment. This means that we need to perform biodegradability and disintegration tests with different experimental conditions, or indeed at ambient temperature lower than 30 degrees, and we need to provide the more than 90% of biodegradability within 12 months. So the time of the biodegradation test is increased, referred to the previous one, the industrial compostability test, and also for the disintegration test that can last for 6 months. Also in this case, we have to perform the test at ambient temperature. In this way, we can provide the certification and the compliance with the home compostability and end-of-life assessment. So, the main conclusion, we need to provide a further validation for the ECOFUNCO product final demonstrators. Here the picture, more or less the one already provided by the colleagues in the project. And we wanted to validate and let's say firstly assess and validate for the OK Compost Home and OK Biodegradable soil, water and marine performance of these final demonstrators. So in different environments, we wanted to assess the final behavior of the material and products that we obtained from the project. So I'd like to thank all of you for the attention. If there are any questions.
Thank you, Francesca. And this was a very interesting presentation to understand the importance of life cycle assessment and advancing towards sustainability on packaging. Thank you.